Hello, thanks for joining. So, last time with AWS, we have seen somewhat similar implementation wherein we have created an API gateway that was further redirecting the requests to AWS Lambda function, and then Lambda function was performing operations over DynamoDB. So, this is what we have seen already in the same playlist. If you go to the previous video, that is all covered. The additional thing in this video is that we are going to achieve this all through AWS CloudFormation. In the last video, if you want to see step by step everything, as in how things are working, how we are creating the API gateway and configuring all the resources, methods, the connectivity with the Lambda function, as well as doing the deployment of that API gateway, and how we are creating the AWS Lambda function from scratch, and even the DynamoDB table. If you are interested in that, then probably I really recommend if you first watch the previous video in the same playlist. I'll also provide you the URL into the description for the previous video. And then as a next step, in this session we are going to cover it all through CloudFormation. So there is a CloudFormation template, we can just use that, and everything will be done through CloudFormation, like API gateway creation, the deployment of API gateway, Lambda function, and then DynamoDB. And then ultimately we are going to test that. All right, from learning perspective, we'll be learning CloudFormation concepts. Then we also will be learning API gateway, Lambda, IAM role, and DynamoDB CloudFormation requirements. The prerequisites for the same is that one should have AWS account to perform or implement this learning. Then you can download the resources, which is nothing but just one YAML file that you can download from the GitHub. I'll also provide this URL into the description of this video. And then recommended to watch is the previous video, because in that we have done everything from scratch and manually directly into AWS console. But this video is more about CloudFormation. Just get the YAML file, download into your local, or maybe just copy the content of the file, put it into CloudFormation, and just execute, and everything will be done. So we'll see that also into the action. All right, so we are looking at the blueprint of our CloudFormation. Each of this individual entities, such as IAM role, DynamoDB table, Lambda function, and so on, are considered as individual resources in the CloudFormation. And the pink arrow line shows dependency between two resources, and then the black arrow line shows the reference and association between two resources. So we can, by looking at this blueprint, we can say the DynamoDB table is dependent on IAM role, and the Lambda function is dependent on DynamoDB table, and so on. And then the black arrow line shows that Lambda function is using the IAM role. In fact, it is using the ARN of the IAM role, which has just been created, so that it can use this IAM role and associate that ARN of IAM role with this Lambda function. The other quick thing is about the REST API, the API gateway. So first it will create a REST API. Inside that it will create resource, and then inside resource we are going to create the API gateway method, and then we'll deploy the API, and then ultimately we'll grant the REST API a permission to the Lambda function, which we'll create as part of CloudFormation. So now we are going to switch over to our CloudFormation template. We'll just take a quick look of how it looks and the statements. What does it mean when we place them into the CloudFormation? All right, so we are looking at the CloudFormation template right now. The resources that we are going to create is Lambda function, DynamoDB table, the complete suite and deployment of API gateway, and then we'll also create IAM role and grant our REST API a permission to execute Lambda function. And then we have got some parameters also. So first of all, we can look at the parameters. There are four parameters: Lambda function name, DynamoDB table name, the API name, and environment name. There is a default value provided. All right, so after parameters, now we can look at Lambda function resources, and we can see how we are handling things here. The inside the Lambda function, the type is we have provided AWS Lambda function. The properties, first property is code that we have defined, and then after giving the zip file, we have just provided entire code of our Lambda function. There is an alternative way also to do so, wherein we can just put our Lambda function into S3 bucket, and we can refer that S3 bucket location into CloudFormation template. For our demonstration purposes, I have just pasted this code over here. Yeah. And then other properties are function name. So we are using ref reference over here, and then this is basically referring to the parameter name. And then the handler, we are providing index.handler, the runtime node.js 12, and role. The so so with this role, if you remember the black arrow, directional arrow, that is something we are referring over here. So what we are asking it is get attribute of iam role dot arn. So iam role is basically the exact name of a resource that we are creating over here. You see, iam role, and then we are asking Lambda function to get attribute iam role dot arn. So once this CloudFormation get the arn of that iam role, it is going to associate the same role with the Lambda function with appropriate rights. All right, and then in the end, it just says it depends on the DynamoDB table creation. All right, so now we can get on to the DynamoDB table over here. The type, we have provided AWS DynamoDB table. The properties, table name, again ref reference, referring the parameter that we are going to give value to when we create a stack. The attribute definitions, such as attribute name, so just one column we are going to create. DynamoDB is NoSQL, so basically we don't have to come up with any specific structure or something. We can just give one column to start with. I'm just giving ID, you can name it anything else. The attribute type is going to be string, that's why S is mentioned. The key schema, the only one column as of now that we are creating is ID, and the key type is hash for that. The provision throughput for read and write capacity is 5, just default values I'm providing over here. And then this depends on the IAM role creation. All right, the next one is maybe we can look at IAM role first before we get into this API gateway entire suite. So the type we have mentioned, and then inside the statement effect, we are saying allow this service, as in lambda dot amazon aws.com. So what does it exactly mean? It means that this IAM role can only be used along with the Lambda function, and that is why we are providing this service lambda.amazonaws.com. The action that it can perform is it can assume role. So when Lambda function will be executed, Lambda function will be able to assume this role. Inside the policies, we are saying the policy API Lambda DB. So one policy will be created with this name, and then inside this we are saying effect allow actions onto DynamoDB to do perform all these functions. and we are just providing resource as asterisk. So basically, not any specific DynamoDB table, but any DynamoDB table that we will provide for the execution. And then we are performing another allow, and action this time is on logs, so it can create log stream. So whenever lambda function will be executed, it can just it can capture all the logs and create a log stream, create log groups, and put log events into the stream and group, uh, into the stream. And then resources again is asterisk, so any log stream or group we are talking about here. All right, so this is all about IAM role. So for API Gateway Suite, we can start looking from the parent. So first of all, REST API will be created. As part of this REST API creation, we are just providing the reference name, like the API name, which is basically coming from the parameters, and then it depends on the Lambda function. So right after this, API gateway resource will be created, and inside API gateway resource we are taking a reference from API gateway REST API which we have created over here, and then we are taking basically the REST API ID, and this ID will further be used to create a resource. And then inside parent ID we are also getting attribute like API Gateway REST API, and then root resource ID. The path part is basically when it will create an API, it will use Lambda function name also as part of the path in there that we'll see shortly, and then it depends on API Gateway REST API. Right. After this, a method will be created, which is again using the references from REST API and also getting the resource ID, which we have created. The HTTP method for our demonstration purposes, we are going to use post. The authorization type is we are setting as none. The method responses we are setting up over here, and then the integration. This integration type AWS, which is basically used for Lambda proxy related integrations, and then integration responses, status code, and then the URI we are providing over here. This is the URI for our Lambda function. So this is how we are using Lambda function name ARN over here inside the to create this ARN basically. And then Lambda function name ARN, we are getting the value of this variable to be used inside this ARN by using get attribute lambda function dot ARN. Alright, once a method is created, then we'll do the deployment of that API. The type is this, and then REST API ID, API gateway REST API, the ID we are fetching again, and then the stage name, one another parameter we are using environment name that we have provided by default as production, and then it depends on API gateway method. And quickly, just this last one, API gateway permission. So by doing this, we are providing our API gateway, the REST API, a permission to call Lambda function, to invoke our Lambda function. All right, so now we'll switch over to AWS console and see all of this in action. Alright, so here we are at my GitHub repository, and the URL for the same I have provided in the description of the video too. So you can just hit that direct URL and it will land you to this page. So either you can download this file, or maybe you can just copy the content of the file and take it over along with you onto the AWS console. All right, so switching over to our AWS console, and then we can look for services, search for CloudFormation. Right, so inside CloudFormation we can create a stack. Now, if you already have downloaded the template file, then you can say template is ready and then upload a template file and choose file and upload a template, the YAML file. Or if you have copied the contents from GitHub repository, then probably you can go to create template in Designer and then click on create template in Designer. All right, so once here, then we can go to template over here and then choose template language as YAML. Delete the existing one-line text that was there, and we'll paste our CloudFormation template YAML file content into it, and then it will say designer is out of date. So to refresh this, we'll click on this refresh button. So here we are, it has created a diagram, our blueprint for us, and this does contain everything: IAM role, DynamoDB table, Lambda function, all API gateway related stuff. Now to validate the template, we can click on this right check button over here. So this is all right, so our template is valid. Now if you want to download this this blueprint, this image of CloudFormation, then you can click onto this. You can download the diagram as an image. For now we have to create this stack because our template is already valid. So I'll just click on this create a stack button over here. All right, so now it is going to save this template in Amazon S3 URL. By default, it will just create one bucket CF template, and then it will place our template into there. Just click next. All right, and we just have to provide the stack name. So we'll call it stack, and we'll follow the same naming convention: API Lambda DB. All right, so once this is done, okay, so I have to use dash only, no underscores, and click on next. We leave everything else as is, no changes, and then click on next. All right, all these information related to our parameters and everything. Okay, so here it is just asking us to acknowledge because we are creating IAM role. All right, hit on create a stack. Okay, so our create is in progress. This takes around I think 3 minutes to create all our resources. So I'll just pause the video for now. Okay, so our stack is all created, the IAM role, DynamoDB table, Lambda function, and at the end you will see message like your stack name. All right, so we'll quickly go and check all of our resources are created and if they are functioning as they should. So we're gonna start with API Gateway. Go to API Gateway. All right, so this is created. Let's get into API, and the HTTP method post we provided there. So this is also created, and this is an invoking Lambda API Lambda DB over here with HTTP status and everything that we have provided as is. All right, and then we go to stages, and inside stages we see a prod environment is created, and then we expand that and click on the post. And all right, so our deployment is also done. This is the URL of our REST API, which we'll again use to insert, update, or delete the data into DynamoDB. Okay, now we can quickly go and check our Lambda function, Lambda API Lambda DB with runtime. Okay, So here inside Lambda function, we see the Lambda function is created, and even the code is placed over here. And then we can quickly go to the permissions part of it. So inside permissions, we can see that our role name is available over here, and then the resources are mentioned too. So basically this says that the IAM role was created, and then ultimately it is associated with our Lambda function too. Now we can quickly check the DynamoDB table. All right, go to tables, and we can see our DynamoDB table is created too. The partition key, if you remember, we provided ID with type is string, so that is also available there. And then if we go to items, and basically we don't see any item because this is just a newly created table. So we have validated that all our resources are now created as we put in the CloudFormation. So now is the time to test our implementation. In case if you have watched my previous video in the same playlist, where we have build all these resources using the UI, we use Jenkins job to test this implementation. Basically this Jenkins job, I can show you the configuration part also for this. We are just using the build parameter, like select the operation, and then just insert the values such as ID, name, and occupation. And then we are providing API gateway URL also. Then there is a script available inside it, which is ultimately going to invoke the REST API for us in it. And then go with build with parameters. We'll select the operation. As of now our table is empty, so we'll just let create selected as an operation. We'll provide ID, and then let's say name, provide as Charles. The occupation is DevOps, and build it. All right, so this is going to spin another Docker agent as a slave machine and will perform the build. All right, so our build just succeeded. Now we can switch over to AWS console, DynamoDB, and just to verify that our table has got the content. Okay, so it has got ID1, name as Charles, and occupation as DevOps. So yeah, this is it. This is how easy it is to implement the CloudFormation. Okay, so it might happen that you would want to implement the same scenario but want to use the VPC and subnet and security groups that those are recommended by your organization. Or in that case, you can use this another template. Uh, it is with same name in the same directory, which we have which I have provided into the description. It is just that this name is appending with VPC. All right, I hope this content has helped you today. If you like the content, then hit like button and subscribe the channel. Feel free to leave feedback in the comment section. Goodbye and take care until I see you next.